about you all? Welcome to my channel Vijaysphysicssprint. Today we'll discuss about damped oscillations and thereafter forced oscillations. So it's a part of the oscillations, and mostly one question come from this topic in mains and as well as Neet. So what do you mean by the damped oscillations? So already we know about the oscillations. Consider a pendulum is oscillating. The main point taken as O and the extreme points when it is oscillating, the extreme points are taken as A and B. So this is the amplitude. Amplitude, it is A. Of course it is also amplitude equal to A. When it is doing the oscillations with respect to time, the amplitude is decreases and becomes 0. So with respect to time, if amplitude is decreases, the type of oscillations are known as damped oscillations. So damped oscillations means the amplitude of the oscillator is decreases with respect to time. The type of oscillations are known as damped oscillations. Why the amplitude is decreases? Because the air offers resistance force on the oscillator. Due to the resistance force, the amplitude is decreases. The resistance force is known as damped force or damping force. It is indicated with Fd, the damping force. So damping force Fd is directly proportional to velocity of the oscillator in opposite direction. V is the velocity of the oscillator. So Fd equal to minus B into V, where B is known as damping constant. B is known as damping constant and V is the velocity of the oscillator. So one force acting on the oscillator is a damping force, and one more force which is nothing but restoring force. Restoring force already we know, minus Kx, where K is force constant and X is the displacement. So what is the net force? I am writing here net force or total force on the oscillator. Total force nothing but F net. F net is equals to two force acting on oscillator, that is damping force as well as restoring force. Force equation F is equals to MA. A is nothing but d square x by dt square equals to Fd. Restoring force minus Bv and damping force is minus Bv and restoring force equal to minus Kx. Dividing with m on both sides, there is d square x by dt square equal to minus b by m. Velocity is nothing but dx by dt minus k by m into x. Now bring this side, that is d square x by dt square plus b by m dx by dt plus k by m into x, which is equals to 0. So this is the differential equation for damped oscillations. Damped oscillation, this is a differential equation. Small change, small correction for easy remembering. Instead of b by m, it is taken as 2 gamma, and omega k by m is taken as omega naught square. So the equation is modified into d square x by dt square plus 2 gamma dx by dt plus omega naught square x equal to 0. So this is a differential equation for damped oscillations. We know already one more equation, that is d square x by dt square plus omega square x is equal to 0. This is a fundamental equation or the differential equation for simple harmonic motion. This is for simple harmonic motion and this is for damped oscillations. So remember these two differential forms. First one for damped oscillations, 2 gamma dx by dt extra factor. Here simply d square x by dt square plus omega square x is equals to 0. This is for simple harmonic motion. So here 2 gamma, what is 2 gamma? 2 gamma equal to b by m, nothing but gamma equal to b by 2m, and omega naught square equals to k by m. So this is a differential equation. Now what is the solution of this equation? So I am writing here the solution of this differential form, the second order differential equation. So the solution becomes x is equals to a cos omega dash t plus phi. This is a solution of the given differential form. What is A? Is a resultant amplitude. What is A? A is equals to A naught e power minus gamma t. A naught is the initial amplitude. A is the amplitude at instant time. So it is decreases with exponentially in the case of damped oscillations. In undamped oscillations, amplitude remains same. No change in amplitude in undamped oscillations. But whereas in damped oscillations, the amplitude is decreases like this. This is damped oscillations. And that is for undamped oscillations. So the amplitude A equal to A naught e power minus gamma t. This is the amplitude. And what is omega dash? Omega dash is a resultant angular frequency which is equals to root over omega naught square minus gamma square. So it's a resultant angular frequency. Now calculating what is the time period. So omega dash in terms of time period 2 pi by t equal to root over omega naught square minus gamma square. So I am writing here time period t equal to 2 pi by cross multiplication by root over omega naught square minus gamma square. This is a time period in a case of damped oscillations. See this equation in a case of amplitude A equal to A naught e power minus gamma t. In this equation I am writing t as 2m by b. If time value is 2m by b, then what happens for the amplitude? Let us substitute here in the place of t. What happens? See, A equal to A naught e power minus gamma. Gamma is nothing but b by 2m. Already we discussed. And time, it is nothing but 2m by b. So b is cancelled, of course 2m is cancelled out. Therefore A equal to A naught e power minus 1, also written as A equal to A naught by E. So what happens here? Amplitude is decreases by 1 by E times. At the time of 2m by b, amplitude decreases by 1 by E times, and the corresponding time is known as relaxation time. Which time it is? The relaxation time. Generally, it is indicated with the tau, relaxation time. So at time t equal to 2m by b, the amplitude becomes 1 by E times. Corresponding time is known as relaxation time. Same for velocity, 1 by E times. Same for energy, 1 by E times for the relaxation time. So now we'll discuss about forced oscillations. What is meant by the forced oscillations? Forced oscillation means some external force acting on the body, on the oscillator. Due to the external force, if body is going to be oscillate, corresponding oscillations are known as forced oscillation. For example, take a vibration mobile. It is in vibration mode. Kept on the table. What happens? The oscillation of the mobile, it is natural oscillations, and due to the mobile, if the table is going to be oscillate, the type of oscillations are known as forced oscillations. So mobile is in natural oscillations, table it is in forced oscillations. With influence of the external force, the table is going to be oscillating, so corresponding oscillations are known as forced oscillations. So in the forced oscillations on the body, how many forces are acting? First one is a damping force. Already we wrote that is minus BV, the damping force, and restoring force minus Kx. External force is a driven force or external force if driven, or if external can be written as F cos omega t. So here omega is angular frequency, is a driven frequency. I am writing F omega d, and therefore net force. What is the net force on the oscillator under forced oscillations? So F net equal to sum of these three forces: damping force, restoring force, external or driven force, external force. Force equation, F is equals to ma, a is nothing but d square x by dt square, fd minus b, v is nothing but dx by dt, and restoring force, which is equals to minus kx. External or driven force is plus F cos omega dt. Now bring this side, that is m d square x by dt square plus b dx by dt plus kx is equals to F cos omega dt. Dividing with m on both sides, then the equation is modified into d square x by dt square, and this is b by m dx by dt plus k by m into x is equals to f by m cos omega dt. And already we know b by m is nothing but 2 gamma, and k by m indicates omega naught square. So the equation is modified into d square x by dt square plus, this is 2 gamma dx by dt plus, and this is omega naught square x, which is equals to f by m cos omega d into t. So this is the differential equation for forced oscillation. Before we studied about damped oscillations. In the damped oscillations we got only d square x by dt square plus 2 gamma dx by dt plus omega naught square x is equals to 0 for damped oscillations. But in the case of forced oscillations, it is not equal to 0, but which is equal to the external force. This is a differential equation for forced oscillations, and then next we will discuss about what is the solution of this differential equation. So now we will discuss about what is the solution. Solution of forced oscillations. So the solution it is becomes x is equals to a sine omega dt plus phi. A is a resultant amplitude, is a resultant amplitude. What is the resultant amplitude equation? A equal to f by m root over omega naught square minus omega d square plus 4 gamma square omega d square, of course it is square. So this is a resultant amplitude in case of forced oscillations. So here gamma is equals to b by 2m, and omega is a driven frequency, omega naught is an initial angular frequency, and the resultant amplitude, and phi is a phase difference in the case of forced oscillations. So this is about damping and as well as forced oscillations. If you have any doubts, you can ask the doubts in comment box, and please like, share and subscribe my channel and support my channel. Thank you all.